right, so today you are going to work to use elimination or substitution to answer questions about geometric relationships. So we're going to start seeing this algebraic process make its way into geometry problems. And this can be a little bit overwhelming because we're responsible for writing the system of equations and also solving it. As long as we're paying attention to information that we truly know in a situation, writing that system is going to be totally okay. We just need to make sure that we're not making up any information, that we're truly only using facts that we know. Okay, so we're going to use geometric relationships and properties to set up and solve systems of equations. This work ties together ideas of bisection, trisection, midpoint, congruency, perpendicularity, and more in our algebraic work of solving systems of equations by substitution or elimination. So number one, we're given a lot of information and we're asked to find three things. Okay? So for the first few problems, I scaffold this thinking for you. I walk you through what I believe to be really helpful things to do in order to answer these questions rather than just kind of starting from scratch. Okay, so part A asks us to draw and label angle XYZ. We're told to include the trisecting rays in all relative points. So in my given information, I see angle XYZ is trisected by rays YP and YQ. So to get started, I want to draw that angle. Okay, so I want the relative points, meaning I want the points that build the rays, that build the angle. I want to label those X, Y, Z. I want to include the trisecting rays. So I want to include YP, and I want to also include YQ. Okay, so I see that I have one big angle cut into 1, 2, 3 pieces. Trisecting pieces, meaning there's going to be congruent angles. So we're asked to mark all congruent angles in your diagram. Again, trisecting means we're cutting into equal pieces. So all three of these angles need to get the same mark at their vertex. Okay, that means that XWP is congruent to PYQ is congruent to QYZ. And then say label each angle with the expressions given. So XYP is 6x minus 19. So I can say this is 6x minus 19. PYQ is 4y plus 9. And QYZ is x minus y. The next question motivates what we have to do next, okay? Notice there are two variables in the expression, so we're going to need two equations in order to answer the question. When we talk about two equations, we're talking about that system of equations, okay? So we can see here the reason behind needing a system rather than just one equation. So part D says write two true, keyword true, right? We need to write two true equations given your diagram. I want to start off by doing this in my favorite wrong way. We're really quick to add up all angles. So the 6x minus 19, the 4y plus 9, the x minus y, right? We're really quick to add up those angles because we know that makes the larger angle. But what the heck do I set that equal to? There's no value. I don't know what the measure of that big angle is. And we're told to write an equation, so we have to have an equal sign. All we've done here by combining these expressions is we've written an expression that describes the entire angle using the expressions that describe the smaller angles. So this is not going to help us, again, because we have nothing to set it equal to. Sure, we can combine like terms and simplify this expression, but because there is no value to equate it to, this isn't going to help us build a helpful equation that will help us find x and y. Okay, so I'm going to back up and try again. Okay, so adding up every single smaller angle didn't help. Okay, so I've got to think about what might help. Okay, so we have some really powerful markings in our diagram. We know that w or x, y, p and p, y, q are congruent. So I'm going to write that out. X, y, p, the measure of x, y, p is equal to the measure of p, y, q, because those angles are congruent. Those angles are congruent because of the trisecting rays. So here's an equation, 6x minus 19 equals 4y plus 9. That came from setting these top two angles equal to one another. On the same line of thinking, we can recognize that PYQ is congruent to QYZ. So PYQ is congruent to QYZ, again because of those trisecting rays. That means their measures are equal. And here comes another equation that I can write. 4y plus 9 equals x minus y. I challenge you to think of, is there another equation that we could write? I'm not going to dive into it because we told ourselves we need, since we have two variables, we need two equations. Here they are. Okay? I was also instructed in this step to combine like terms in these equations and simplify as much as possible. So I recognize that this first equation, so equation 1, can become 6x minus 4y equals, let's see, 28, I believe, right? If I add that 19 over to the 9, I should get 28. This equation 2 can simplify to, I'll add that y over, that'll give me 3y. I'll subtract, or sorry, adding the y gives me actually 5y. I'll subtract the x and subtract the 9. Okay? So here we're set up to actually do something with these equations, right? We're asked to figure out x and y, so we're going to have to solve that system. So our system is the two equations, 6x minus 4y equals 28, and 5y, and I recognize that my variables aren't stacked on top of each other, so I'm just going to turn those around. I'm going to call that negative x plus 5y equals negative 9. Okay? Again, all I did was I put the negative x first and the 5y second so that I can work to solve the system a little bit more easily. I notice that my x's are of opposite sign, and I could scale this one up to have a matching coefficient to this one. So through multiplying the second equation by 6, I have negative 6x plus 30y, making sure, taking my time, make sure I distribute everything, equals negative 54. I'm not going to change the top equation because it has a coefficient that will help eliminate a variable. The coefficient that will help eliminate the variable is that 6 on the x. So when I add my equations together, my x's cancel. I get 26y equals negative 26, which is not too bad to solve. I divide out the 26, and I find that y equals negative 1. We'll remind ourselves we're solving that system. The system, right? A system of equations has two variables. Right now we've only found one. So we need to take that variable, just like we've done a lot in class. We need to take the value of that variable and plug it back into our equation. I'm going to go ahead and plug it into the second one. There's just some less coefficients going on. So I have that negative x plus 5 times negative 1 equals negative 9. This is negative x minus 5 equals negative 9. If I add over that 5, I'll get negative x equals negative 4. Divide out that negative 1, I get x equals positive 4. So the solution to my system is the points 4, negative 1. Okay? Now it's really important to make sure we don't get lost in the math, right? Lost in the algebra and away from the geometry in the question that was asked. So part F says reread the question and be sure to answer all parts of the question. So back up here, we were asked to find x, y, z, and the measure of angle, or sorry, we have to find x and y and the measure of x, y, z. So I already have x, I already have y. So x equals 4, y equals -1. The measure of angle, x, y, z, well, if I look at x to y to z, I need to figure out all of these and add them together. Remember though that all three of those are the same value because of the trisecting rays. So I really just need to figure out the value of one of these angles and multiply it by 3 to answer this question. So I'll remind myself that x is 4 and y is -1. This looks like a really friendly place to plug that information in. X being 4 minus y -1, that tells me that that angle is 5 degrees. Again, because of those trisecting rays, the other two are also 5 degrees. So this entire angle, the measure of angle XYZ, is 15 degrees. Making that statement completes this problem. So my final answer being x equals y, or sorry, x equals 4, y equals -1, the measure of XYZ equals 15.